We're going to continue on the material for 2001 from the perspective of logic. So one of the things that I talked about in logic course was this idea of a coding phase versus the execution phase. And if you look at the history of events here, first the computational problem comes up. Here's the problem, which is like maybe sorting, and then an algorithm arrives for sorting, right? This is the problem sorting. The algorithm A is quick sort, and then an input arrives, and then we find out, does this algorithm solve this problem on this input, right? So this is saying, what is the output of the algorithm on the input, and does it match out with the computational problem on the same input, right? And so we're going to break it up into two phases. The first phase is the coding phase. During the coding phase, the point of the coding phase is that we don't know the input yet, right? Everything that happens before the input, right? I have to figure out what the problem is. I have to come up with the algorithm for it. And we can get compile time errors here. And then there's the execution phase, which happens after the input comes, and we can have runtime errors. So that's just sort of, here's the idea of table lookup. I think these slides were cut out of 2001, so you've seen them. But I think it's good anyway. We're saying, here's a model of computation called table lookup. It doesn't seem like a good model, but what's the model is we have a table, and the algorithm is a finite table that lists input-output pairs. And how does it compute? Is you give me an input, and if it's there, then I have the answer. And if it's not there, then the algorithm fails, right? So we need to practice being able to say what is the power of this type of algorithm, right? Can table multiply two arbitrary integers in one time step? Well, here, if you give me 2 and 4, I look up 2 and 4, I get 8. So there, it answered it, right? What about, but here, if I ask 2 and 5, then it can't answer it, right? So here's our first order logic statement. And so people who aren't taking 1090 with me, you did do a test 1 on this material, so hopefully you have some of it down. But if you don't follow the first order logic, then you have to holler, right? So here's a statement that says, for every k, if the adversary gives me some k, then I can build a table, here's my table, that can multiply all numbers that are most like k. So here's the game, right? Here's the game. It says for all k, so the adversary gives me an arbitrary value k, right? And then I build this table. You give me k, I build a table. How big will the table be? Well, it's got to multiply numbers up to k. So the k values of x, k values of y, it's a table of size k squared, right? And then the adversary, now it says for all, once we fix the table, right, during during coding phase, we fix the table. And then during the execution phase, the adversary gives me a value x and y to be input. And then, but the promise is that x and y is less than k. And if it's less than k, then I can look up in the table and I get the result. Right, everybody see that? Right, so the point is, during during the coding phase, I can make a table as big as I want, but then the input's going to be bigger later. All right, so here's a different question. Does there exist one table, right? Now, before we had the table depended on the k. You tell me a K, I'll come up with a table. You come up, give me a bigger K, I'll give you a bigger table, right? But now we need one fixed table, but it needs to be finite size. You give me one fixed table. Does it work for every integers X and Y? No, it doesn't. Why? Because I have to come up with one fixed table. And what's true about this table? It needs to be of finite size. And so it can't list every pair of answers. Whatever table we get, it can't list every answer. Y pair, it's not listed, and it won't have the answer. Right? Are people following this kind of game? Partly I did this because it's good for you to know in 2001, difference between different models of computation and the idea of the coding phase versus the execution phase. But partly also I wanted to get us warmed up on first order logic. So